Hello, my name is Musa Akabna, and today I will talk about cloud traffic optimization using SDN software defined networks. Okay, let's start. For the introduction, SDN separates the control plan from the data plan, giving networks more speed, flexibility, centralized management, scalability, automation, and strong security. Network orchestration adds centralized coordination of device, applications, and service, enabling automated workflows. Optimized performance and efficient scaling. Virtualization converts physical resources into virtual ones, allowing independent virtual networks and function to run on the same infrastructure with better resource usage and isolation. When combined, SDN orchestration and virtualization create highly flexible and efficient networks, frameworks that adapt quickly to business needs and support modern technologies like 5G, cloud computing, and IoT. The introduction concludes by stating that this paper provides a bibliographic overview of algorithmic approaches that improve SDN efficiency, accuracy, and security. Now I will talk about the CDN optimization problem. The evaluation of computer networks from traditional distributed control system to centralized SDN paradigm introduced unprecedented flexibility and programmability, but also present new challenges that require innovative optimization solution. The first one is scalability, ensuring the network can efficient handle increasing traffic volumes and growing number of connected devices without performance degradation. The second one is latency, minimizing delays in data transmission, which is critical for real-time application and service that require instant response time. The third one is redundancy, maintaining network availability and reliability by providing backup paths and systems to prevent single point of failure and ensure continuous operation. The fourth one is real-time responsiveness, enabling the network to react instantaneously to change traffic patterns and network condition for optimal resources allocation and quality of service. There's many types of algorithms. The first one is traditional algorithm usage in CDN. The second one, latency optimization algorithm. The third one, dynamic routing algorithm. The fourth one, AI and machine learning algorithm. The five one, load balancing algorithm. The first one. Let's talk about the first one. The first one is traditional algorithm usage in CDN. One study implemented OSPF in an SDN environment using Minint and the Quagga routing suite with a ring topology and GRE tunnels. Metrics such as convergence time, stability, RTT, jitter, delay, and packet loss were measured. Experiment showing improved performance, security, and QoS. Another OSPF based experiment add a dynamic controller to redirect high volume traffic toward paths with available bandwidth to reduce congestion. For BGP, One experiment used an SDN controller to manage BGP routing via OpenFlow, achieving better security and scalability. Another architecture used OpenFlow switches as proxies for traditional BGP routers, running WAGA to gather routing information. The controller successfully learned route security without new protocols or hardware. The second one is latency optimization algorithm. This algorithm aims to minimize the time required for data travel across the network, which is especially important in SDN due to control plan delays. They focus on optimal controller placement, efficient routing of control plan traffic, and effective state management. Methods such as placing controllers closer to the network edge and using algorithms like PAM, partitioned around modest, help reduce latency and improve QoS. One study used mathematical optimization in MATLAB to enhance controller placement and lower propagation delay. The third one is dynamic routing algorithm. This algorithm reduces latency by adjusting routing paths in real time based on network condition. They reroute traffic to avoid congestion and failure, benefiting from SDN's global network view. Latency-aware load balancing distributes traffic based on path load and path delay. In one SDN study, the EVRO, African Vulture Routing Optimization, algorithm was simulated to dynamically optimize routing through initialization, explorations, and development phases, improving load balancing and overall network performance. The third one, or the fourth one now, artificial intelligence machine learning algorithm. Artificial neural networks, ANN, are used in networking for recognizing patterns, detecting anomalies, and predicting traffic. In one study, Minent generated traffic, including normal and attack patterns, was processed by an ANN model to detect threats. Techniques like ADAM and RMS probe improved detection speed and accuracy. Support vector machines, SVM, are used for classification tasks such as traffic categorization and intrusion detection. Another study trained an SVM on a mix of normal and malware traffic to classify new patterns as malware or normal using features like bytes, consts, and packet rates, evaluating performance through detection and false positive rates. The last one is load balancing algorithm. Load balancing algorithm aim to efficiently distribute network traffic across multiple paths or servers to improve performance, reliability, and scalability. Research focus on a method that dynamically allocated resource and minimize congestion, often using heuristic or approximation techniques due to problem complexity. There's common strategy include the first one round robin scheduling, and the second one is late connection. The third one white load balancing. The fourth one is dynamic load balancing. In the conclusion, heuristic routing, and the traffic-related algorithm each play an important role in improving SDN performance, reliability, and adaptability. The choice of algorithm depends on network goals, architecture, and the traffic requirements. General algorithms are valued for flexibility. Latency-focused algorithms are essential for the life-sensitive applications like a VoIP, and load balancing algorithms are suited for high traffic environments. The paper's review helps readers understand the available algorithm options and how they can apply to optimize SDN environments. It provides a comparative view of algorithm capabilities, supporting network designer in selecting suitable method. In conclusion, the study offers a broad overview of traditional, heuristic, and AI-based algorithms used in CDN, highlighting their roles in improving security, scalability, and performance. However, challenges remains such as interoperability across different vendors, releasing against advanced cyber threats, and adapting to dynamic network condition. Future progress will require collaboration between researchers and vendors to develop standardized, flexible, and adaptable algorithm frameworks. Thank you for listening, and goodbye.